Every day on the job is like going into battle.
1,500 feet. Right hand side? Right hand side. Check, bullseye, nice drop.
The forest fire is a natural part of the ecosystem, but when it burns out of control, its destructive power can be awesome. Fire control centers operate like paramilitary organizations, on standby around the clock. Another red alert. We follow Al Heimers, captain of a CL-215 water bomber, during Ontario's worst fire season in 50 years. Heimers and co-pilot Jim DePiero are based in Dryden, the fire capital of the province. For Al, this is a war, and the forest fire is the enemy.
It's like a David and Goliath. You know, you're the David and the fire's Goliath, where it doesn't seem anything you do will allow you to get that fire under control. It's like Goliath is winning, and it is. It is a battle zone out there. It really is. As far as I'm concerned, I look at it as it's probably as close to a war as I'll ever get. Hopefully it will be.
The 73rd fire of the season is burning north of Dryden near Good Lake. The fire is classified as aggressive, spreading at the rate of 1 meter a minute. If they are to contain it, water bombers must get to it before the wind changes.
And Red Lake Radio, Tanker 262 is clearing your zone to the south this time.
Al Heimers regards the plane as the hero of this mission. The Canadair CL-215 water bomber is the only plane ever designed specifically for firefighting. It has changed the way fires are fought. Firefighting from the air is a dangerous business. The precise coordination of pilots, planes, and attack strategy is the responsibility of the air attack officer, who flies in the Bird Dog plane.
Bird Dog 1 off Dryden, heading Dryden 57 and going channel 7. Do you have ETA to the fire?
Estimating the fire in 10 minutes. We have Tanker 262 working air-to-air frequency 122.65. Could I have a fire boss en route to fire, please?
You can check the fire boss will be Garth Wintle. Helmet.
The Bird Dog, of course, is a smaller twin-engine airplane that flies with the air tankers, and what they do is they are the air traffic controller, the coordinator of the whole show, and everybody is talking to them. Nothing happens on a fire without talking to them. Nobody moves on a fire without clearance from them. So they are, in essence, the air traffic controller on the fire.
Well, Pete, we're inbound that fire from Red Lake. We're 80 back. We have it visual, and she's a giant, eh? Yeah, that's one big fire over there. Oh, how does a fire get like this?
Jim and I were just finishing our 7th season together as a team on the CL-215. Actually, we had a pretty good record. Up to the start of this season, actually, we had only ever lost one fire that we had initial attacked with the CL-215, and it was a fire in the old growth forest in Temagami, and we'll remember that fire number forever. It was Temagami 5.
Look at the jumps out front right now. You see the jumps from here. Yeah. Yeah, Bird Dog, it's 262. We're 12 minutes back this time. Now we can see the jump fires out front there now. Roger, Tanker 262.
Bob Gardam, the air attack officer, plans the first water drop.
I think there's a jump fire just past the head there. Maybe we can, you can come around the head and we'll see if we can get a line on it.
Okay.
We'll go down low level and do a bomb run inspection. The first 5 minutes on a fire is your critical time. It's potential for high stress right at that time period. That's when all your aircraft are converging on the scene, and so you've got to deal with an air traffic problem. So your safety is your number one concern right off the bat.
Yeah, okay, we're just coming up to the back end of the fire here. We got you in sight. On an island, there was probably a campfire left burning, eh?
We take a part of the fire that the ground crews can't get at. In most cases, the head, the hottest section of the fire. That's where it's up, it's burning, and it's advancing. So what the ground crews will do is they'll get set up with their hoses and stuff, and they might start coming up the back end, working the flanks. Basically, our job is to stop the advance of the fire, bring it into a manageable state, turn it over to the fire crews, and they actually do the extinguishing of the fire. The CL-215 is the greatest firefighting tool that's ever been designed and built. It's revolutionized firefighting in Ontario. It's extremely at home in the elements on a fire. It's designed for the exact elements that you face. It's highly maneuverable, it's got lots of power, it's fast.
Al loads up the CL-215 with ammunition, 12,000 pounds of water.
The CL-215 is the primary initial attack tool on the forest fire, and I guess the reason being that it is relied on so heavily for initial attack is there is no other tools available that allows you to deliver 12,000 pounds of water to a fire in minutes. In optimum conditions where you get to a lake very close to the fire, if they're side by side, we've worked the circuit as tight as 1 minute and 10 seconds from the time we drop our load till we're back dropping another load.
Right hand side? Right hand side. Check bullseye, nice job.
Once you do that first 1 or 2 loads, the pickup lake has been established, the attack strategy on the fire has been established, and then it just seems to work into a rhythm.
The routine helps the pilots to focus on the job and not the danger.
Every day in firefighting, you're faced with a lot of dangers. Flying the airplane itself with the possibility of a breakdown, an engine failure. It's always in your mind. Plays, a lot of stress in it. The air attack leader, allowing a helicopter to get in your way, or the possibilities of a mid-air collision. There's just the elements you're flying in with a big, heavy airplane and maneuvering it low over the trees and in windy, gusty conditions.
Poor ventilation, high temperatures, and turbulence make conditions in the cockpit punishing. To fly the CL-215, pilots must be in top shape.
Physically, it requires a lot of upper body strength, especially on the controls. Scooping, it's very heavy. We don't have the luxuries of the hydraulic assisted controls and stuff. It's all manual steering.
Pushed to the limits of endurance, pilots depend on the rush of adrenaline to keep them going.
62's inbound, looking for a target.
262, you can check, we're just turning final. It'll be the same target.
Okay, how's this line looking?
Okay, line's starting to look good. Yeah, there's your jump fire. Okay, level out right there. That should be good.
Okay.
Right on.
You start coming down a bit there, Phil. Try not to get away on us, eh?
Yeah, with the nozzle cruise working, that's where I'd like you to drop the load right at the base of that long finger that stretches out there. And then, yeah, come on the line you are and have it come straight through like you are now. your nose there now, bud.
A chemical solution is injected into the water tanks, which produces a fire-retardant foam more effective than water.
The opponent can be very unpredictable, and you learn a few tricks of the trade, and you learn some of the moves that the opponent will make, and usually with the machines we have now and the firefighting equipment we have is in most cases we can beat Goliath.
62, you can check the bird dogs on the final. We can get you to put this load right where you put your last load there.
Okay, we checked that. Speed her up with her phone.
The bird dog calculates that if it hits the target, this will be the last load.
Short final, target elevation 1,500 feet. Target now.
I guess we got this one under control. It's another one in the bag for us.
Good one. We're out of here. Yeah. Okay, Mike, we're out of here. Thanks for that.
After several hours of air attack, Dryden Fire number 73 is officially classified as being held. Ground crews will finish the job. As Jim and Al return to base, they savor their victory while they can. After weeks of hot weather, the bush is tinder dry. With strong winds and lightning in the forecast, one thing is certain: Goliath, the age-old enemy, will be back. Coming up, the history of water bombing.
The airline life never really appealed to me. I was a bush pilot. I was raised in the bush. I love flying the bush. Our whole careers are molded around working off the water in different lakes. It's so natural for us because the vast majority of the guys that are on the CL-215s have more time on water than they do on land.
The first Canadian bush pilots were World War I flying aces who came home looking for adventure. Some found jobs surveying timber in the Canadian North and were assigned to fly the Curtiss HS-2L flying boat. Flying the Curtiss was an adventure indeed. The temperamental engine had a tendency to fail in mid-flight, and pilots needed nerves of steel and split-second timing to restart them. Despite their drawbacks, the flying boats were used to create the first accurate maps of the North. After one such flight, the pilot reported the location and condition of a major forest fire. Using these coordinates, firefighters were dispatched to the area. The whole operation was declared a great success, and from that point on, planes supplemented observation towers in scouting for fires. The Nordine Norseman, the first Canadian bush plane, appeared in 1935. It was quickly adopted for firefighting because it was tough, dependable, and could carry up to 10 men with their equipment into remote locations. A novel firefighting strategy that required rigorous training was known as smoke jumping. In areas where planes couldn't land, teams of firefighters parachuted as close as possible to the heart of the fire. The objective? To suit up and be airborne in minutes. Once they had taken the plunge, smoke jumpers could only hope their equipment landed nearby. Everything changed when the concept of bombing was applied against another enemy, fire.
World War II probably paved the way as much as anything else for the thought of water bombing. Many pilots come back from overseas and they had been bombing bridges and trains and all sorts of things, and began to think, why not use water as a bomb and use it on a forest fire? This thought developed fairly quickly after the war, and people began seriously to think that this might be a way of doing things.
Former Air Force pilot Knox Hawkshaw, an aeronautical engineer at Field Aviation, perfected the water bombing system still used today.
At that point, however, no one really knew what was required of a water bomb load to be effective against a fire. They filled up the old Curtiss flying boat with paper bags of water and they dropped them over the side like this. And of course, there's a couple of gallons of water here, a couple of gallons of water there, and it just didn't put the fires out, but the idea was there.
But the paper bag scheme was clearly a case of back to the drawing board. What was missing in the quest for a water bomber was the right plane. In 1947, de Havilland produced it, the Beaver.
Well, the Beaver was probably the first real good airplane. The Norseman was a fine airplane, but the Beaver was better, and could carry a good load. And some people, Tom Cook in particular, and Sault Ste. Marie and some engineers out there, decided to get the water out in a big hurry. So they put rollover tanks on top of the floats, and quite an ingenious arrangement.
After serving as a bomber pilot in World War II, Tom Cook joined the Ontario Department of Lands and Forests, where he perfected the use of rollover tanks on the Beaver.
This is Beaver OPS. It's the second Beaver was ever produced. The first one was a prototype. This is actually the first operational Beaver. It was built in 1948, so it's now 47 years old. There were some 1,600 Beavers built, and there's still almost 1,000 of them flying in various parts of the world, all over the world for that matter. So we consider the Beaver to be the greatest bush plane that was ever built, and it's far from on its last legs yet, even after almost 50 years.
Once they solved the problem of how to fill the tanks, they had to make sure that the airplane could take off.
We finally did get it going, and I had an opportunity early in it to work on a fire in 57 near Sudbury, and it proved so successful that before next year, all the aircraft were equipped the same way.
They'd fill it full of water, and then when they wanted to get over the fire, they'd roll the thing over the water, fall out, and the tank would roll back for the next load. What they did was put the center of gravity of the loaded tank on one side of the pivot point, the empty tank on the other side of the pivot point, so all they had to do was unlatch the thing, the water would roll it over. Once the water was out, the other center of gravity would take over, and it rolled back and latch itself. It was quite well done. They rolled them outboard at first, and this wasn't all that great because the water spilled over the top of the floats and it was quite diversion as it went down to the ground. They then thought, well, maybe we better roll them inboard and get all the water coming down together. So that also was an improvement. And then with the Otter airplane, they put one big tank under the center of the airplane and then rolled it over in between the floats and the water came straight down. These early systems, while they were great for the time, all lacked one important factor that is now well known, and that is that the water should fall in one cohesive mass all straight down, rather than being nudged aside by falling over floats or wing struts or float struts or what have you. So we started looking for an airplane that we could, first off, deliver a bigger load, and secondly, have it fall the way we wanted it to. And the Council just appeared to be the real answer. In fact, back in those days, I used to say that one would think that the designer of the Council ultimately had water bombing in mind.
The Consolidated Cancel, also known as the Catalina PBY, was a World War II bomber used for tracking submarines.
Canso is a big enough airplane to carry a very healthy load of water, like 8,000 pounds, and still have enough fuel for several hours of flying. It's a docile airplane, easy to fly, that is, from a controllability standpoint. Now, the pilots had to have strong muscles because it's heavy on the stick. And it had a great record of reliability. We started working on the Canso in 1960 and developed a system that dropped the water right through the bottom of the hull, which is a no-no. Many people would say, in fact, I myself earlier said no one in his right mind would ever do this, but it had to be done, so we cut holes in the bottom of the airplane and put a water scoop on it, which we call a probe, and presented this concept to two of the Canadian provinces, Newfoundland and Quebec, and the word was go. The doors we designed for the Canso were hinged on the outboard edge, and they opened up this way, one on each side of the hull. In order for the doors to open quickly, we didn't drive them open, we let them free fall. And not only was it a free fall, but we put a heavy spring in it to open them even more quickly. So this meant that all that happened when the pilot pushed the dump button was the doors, there was no hydraulics, no electric, anything, just they were unlatched. And the spring and the free fall, down they went. And then, of course, for closing, the hydraulics came into action. As soon as the pilot takes his finger off the dump button, the doors close, and all the retracting mechanism of the doors goes back to a settled position. The probe is a water scoop. That is a tube facing into a stream of something or other, air, water, or what have you. And the speed of the water coming to this open tube drove it right through up the pipe and into the tanks. It causes quite a drag, as one can imagine. Like you stick your finger out over the side of a motorboat, and that much finger will pull your arm back. That's at, say, 30 miles an hour. Imagine at 70 miles an hour, because the drag is proportional to the square of the speed. Like you go twice as fast, you get 4 times as much drag. So these had to be pretty strong, and they actually they're not as big as people would think. And the ones we put on the Canso loaded the airplane in 14 seconds. That's 8,000 pounds in 14 seconds. And then, of course, the probe retracts so that drag disappears, and you can almost feel the airplane nudge ahead with the loss of this drag, and it just gets airborne right now. Canso became very successful, and Ontario decided that we might do the same thing in the float planes and put the water in the floats instead of these rollover tanks. The first one we did was the Otter. After the Otter went out to water bomb and forest fires, it turned out pretty good, way better than the rollover tanks. Ontario decided, well, let's do the same thing to the Turbo Beaver. After that, the Twin Otter was designed and introduced to the aviation world, and so we did the same thing to that. But the Twin Otter turned out to be the best of all three. It was a great airplane. The distribution of the water, we call it the ground pattern, how the water fell on the ground, and the density and the uniformity of coverage was the best we'd ever seen. I've always felt fortunate to be associated with the aviation industry and to have been a pilot myself. I don't know of any other endeavor man is involved in that can so completely enrapture one. The dedication is just unreal. Well, this is a sort of a dream. I got the idea to do it when the real Cansos became successful, and it's really a retirement project. The minute I had time, I started at it, and 3.5 years later, I had this. It's an exact scale, 1/8 scale replica of the first water bomber that we made, which was CF-NWY, as is the registration on this one. It is a flying model. It has all the services that the real Canso does, like undercarriage, floats, wingtip floats, landing lights, navigation lights, bomb doors, water probe, and all the control surfaces, as well as a good deal of incidental detail which you can see around. So it looks very much like NWI. I think from a distance in the picture you couldn't tell the difference. This system, which turned out to be so useful on all these airplanes, was, of course, a real challenge from day one. I guess probably the best thing I've ever done in engineering. It's still going, it's still reliable. Even now into the Canadair CL-215, the same system is still functioning.
Next, a technical tour of the CL-215 water bomber.
The CL-215 is everything you ever wished the Cancel could be. It's more powerful, it's more maneuverable, it's easier to fly. So for me, the progression to the CL-215 was a natural progression.
The first CL-215 was manufactured by Canadair in 1967.
Right from the concept, it was the first aircraft that was purposely designed and built to optimally meet that firefighting role. That was the express purpose for which it was built. And to the best of our knowledge, that's the only aircraft that was ever built for that role, expressly for that role. There have been lots of other aircraft modified to meet the role, but that's the only one that was purpose-built for that role.
The president of Canadair's Amphibious Aircraft Division, Jim Cherry.
There was 125 of them built, and most of them were sold in Western Europe, and the balance of them were sold mostly in Canada, the various provinces of Canada. And of the 125 built, 102 of them are still flying today. So very rugged, very well put together airplane. And when you consider the nature of the role that it has, and the rough terrain and the rough sort of role that it takes on, it's a terrific record of durability. As captain of this airplane, one of my responsibilities is the bottom check as part of the walk around. Jim, as co-pilot, is required to do the top section of the aircraft, the top check. So as part of the bottom check, I'll bring you around and I'll show you some of the features of the CL-215. As you can see, as you're aware, it's an amphibian aircraft. So basically what happens is it's equally as comfortable on land as it is in water. What we do is when we select the gear up here, the nose gear goes up and the nose doors close. And as the main gear folds up against the fuselage, you end up with the hull of a boat.
The hull of the plane is constructed like a boat. It is divided into watertight compartments so that if one compartment is damaged, it won't sink.
What we have under here is we have the doors, the drop doors, which are the bottom of the water tanks. And what they do is they also make up part of the hull. There's two separate tanks in the CL-215, consisting of 600 imperial gallons each. What these doors, of course, are closed whenever we're scooping water. They're hydraulically closed and free fall open.
The weight of the water pushes the doors open.
This is very critical, this area. We want to make sure that there's no bends, ripples in the doors. We want to make sure there's shock dampening systems up in here to slow the door down so the hinges aren't being fatigued every time it opens. We've got the actuator rods, door seals we have a look at every day to ensure that there's no cracks in the seals and stuff. Once we check that, then we just have a basic look. We've got our overflows here. That's where the top of the tank is.
Pilots don't have to worry about overfilling the CL-215 because excess water overflows out of the top of the tanks.
It allows, on an overfill, the water to come overboard, but also as you drop, because the water goes out so fast, it takes 1.25 seconds to empty it. The air has to allow air to get back into the tanks, or else you will collapse your tanks. So it has a multi-purpose. We want to make sure there's no blockage or anything on that. The engine above you, my job is to check the engines over from down below. What we have up on the exhaust stacks, you can see there's titanium heat shields. It's critical that those are in place to protect the heated exhaust from getting into the auxiliary sections and stuff and burning into the auxiliary section, which can cause an engine fire. So those are critical. We want to have a look at those. What we do is we have a quick look at the propeller. We want to make sure there's been no strikes on the propeller. The propeller blades are set according to manufacturer. As you notice up top, there's little red marks up top, right where the propeller meets the domes. You want to make sure those are lined up. That tells us that the pitch angle on the propeller is the way we want it. You notice on the CL215 the thickness of the wing, and that allows for an extreme amount of lift, and that's what makes it an extremely good firefighting aircraft, is because of the amount of lift that the wing will generate. We have our wing sponsons. What we want to do is, again, make sure these there's no bangs, no nicks. There's a couple drain plugs on them. We want to make sure the drain plugs are in place, and we want to make sure that they're fastened on tight. The sponsons serve really no purpose as far as the firefighting aspect of it goes. Where they come into play is if we ever do full stops on the water, whether we have to abort a takeoff and due to engine problems or some sort of an emergency, they're what keeps the airplane upright. With, of course, being a single hull, it would just tip right over. So these are what help keep it level in the water. We have a look at our flight controls. We have the ailerons, and next to the aileron, of course, is the flap. Another one of the characteristics of the CL215 is the size of the flaps. We had engineers one time measure. The flap is the exact same size as a de Havilland Beaver wing, to give you some sort of indication as to the size of the flap on this thing. And the airplane is, without flap, it wouldn't be much of an airplane. The flaps are what really make it what it is. And then we move on to the underside of the hull, the back end of the hull here, the step compartment. And this is where the hydraulic probe systems are, which is what loads the CL215. There's one separate probe for each water tank. It takes us approximately 10 seconds to take on 12,000 pounds of water, or 1,200 imperial gallons, 600 gallons through each probe. So it works out the equivalent of about 2 45-gallon drums of water going through this probe every second. And as you can see by the size of it, it's basically 4 inches by 6 inches. It's an extremely small area to have that much water go through it.
Because the plane travels at speeds of 90 miles an hour, the water is forced up through the probe into a series of pipes, through flapper doors, and into the tanks. Water level indicators tell the pilot when the tanks are full and he can take off.
Probe, sir. 262, sir. Yeah, far over. Final part there now.
I suppose one of the downfalls that I see, and a lot of the guys see of the CL215 is the engine that powered. The Pratt & Whitney R2800 is an extremely fine engine. It's a fairly reliable engine, but it's also 50 years old. And with old technology comes problems. When you take, for example, this last little fire flap that we were on, in 6 days we did 313 takeoff and landings in a 6-day period. When you're staring at the trees and it's hot and you're heavy and you're coming over the trees, it does weigh heavy on you. The fact that we do have this older technology, I think the designers would fall down if they ever saw these engines doing 50 years later what they're doing.
After years of design, a new water bomber, the CL415, is rolling off the assembly line at Canadaire's Montreal plant. 415s have been bought by several European countries and by the province of Quebec, but there's a hefty price tag, $22 million a plane.
basically what the 415 has, the major differences between the 415 and the earlier aircraft, and the thing that made it possible, was the availability of lightweight, high-powered turbine engines. On the newer aircraft, we've got 2 Pratt & Whitney turbines, and the power difference between these aircraft and the older piston aircraft is phenomenal. This is a very, very dangerous mission that these people are performing. And anything that we could add to this aircraft to improve their chances and improve their reliability in these missions is very, very important. And that's a big advantage that the 415 has over the 215. The rate of climb, the ability to maneuver quicker, to get out of trouble quicker if they had to, is a big safety factor and a big improvement over the older aircraft.
Al Heimer's ambition has been to fly the 415. So we arranged a test flight to see whether the new plane would live up to his expectations.
We're going to just go and see Yves Maho here. Yves Maho is he's the chief test pilot for Canadair. He's actually a legend as far as water bomber pilots go. Yves, good to see you again.
It's a pleasure. Do you want to come on board?
Excellent.
What's your head? It's like the 215.
Well, I got to admit, Yves, in the cockpit, there's not too much that looks familiar.
Is it different than yours?
It's a little bit different.
Before it loads up with water, the 415 has a rate of climb of almost 1,400 feet per minute.
The one thing I noticed right off the bat is the quietness and the smoothness. There's no vibrations, no shakes or anything, with the 215, of course, is prone to. But it's also just the speed, the acceleration is so much greater. The rate of climb is so much greater. The boosted controls, first time I've ever flown anything to do with the water bomber with boosted controls, and there's no doubt it's a lot lighter on the controls.
The real test is how the 415 scoops and drops water.
We've got about a 2,200 foot per minute descent here, 2,000 foot per minute descent coming in here, which with a 215 is virtually impossible to do without damaging the engines. Okay, our probes are down.
Yeah. Raise the nose a little bit, slow down, cut your power, slowly, cut your power, nose up a little bit, cut your power, slowly. There you are.
So the approach speeds are about the same. We're 90 knots here now, just going into the flare.
Yes.
We're coming out of the water.
First reduction.
Okay, 15 flaps still hanging.
Yeah.
Okay.
So we want to do a salvo.
Sure.
And you can punch that salvo.
Okay, we're armed. 4 doors are armed.
Nobody around, so you
Nobody's around. Okay. Okay, train automatic, 4-door.
Okay.
Okay, and we're dropping. Impressive. There's no doubt, Eve, this is the future of water bombing.
Encouraged by the new technology, Al now turns his attention back to another emergency on the CL-215.
You know, when you're dealing with tanker numbers and magnets are being moved around on a map, you know, to different bases, and it's just a magnet, or the airplane is just a tanker number. And quite often it's forgot that behind those tanker numbers there's human beings, there's families, and it's hard for a lot of families. I know for myself, my children have a hard time understanding that you're not going to be there for the baseball game. What I try and do is I try and bring my kids into it as much as possible. I try and keep them genuinely interested in my job.
So for Al Heimers, family time in the summer is like wartime leave, brief.
They never understand when you're going out the door with your bag in the morning and you can't tell them whether you'll see them at supper or in 2 weeks.
With as many as 100 new fires reported some days, crews across the province are now on continuous red alert.
2962, Uniform Mike, we'll call airborne 11. Roger, and what L2 you plan for your work?
We have a dispatch for a tanker at Bird Dog out of Dryden to 62560.
Thunder Bay Radio, Commander Fox, Mike, Uniform Mike 221.
And Bird Dog 1 Dryden region, you can check the base map as 62560, bearing 082 degrees, distance 50 miles. This will be Dryden Fire 56, over.
The latest alert, a fire burning out of control on an island in the northwest corner of the province. If the fire jumps to the mainland, there is nothing to stop it from spreading indefinitely. Whole communities may have to be evacuated.
The season we're in right now in Ontario probably will go down as the worst fire season that we've ever been faced with. We've been out bombing in 50-knot winds, 48 knots, 45-knot winds. I've never experienced these conditions for this length of time ever since I've been flying water bombers.
So we're ready for the scoop, eh?
Yeah, he said take a good look. He said lots of reefs.
Yeah, we're going to take a look right down the center between these islands. I'll take 10 flap there, Jim. Okay, I got a reef in sight right here. There's one right out in the center here. Not quite halfway between these two islands.
I guess to be a good pilot, you have to have a lot of self-discipline. You're faced with a never-ending, changing environment, and you have to be able to make decisions and think in your feet. And pilots, no doubt, have big egos. And I guess that's probably one of the aspects to make a good pilot, is you have to be proud of yourself. You have to be proud of what you're doing.
This is on islands. We might have a chance at her.
Yeah, you bet. When it stays where it is, it'll help us a lot.
Al and Jim survey the area targeted by the Bird Dog to see where the fire is most likely to spread.
Yeah, we can just go right at it rather than trying to get too fancy, eh, Mike?
Roger.
Okay.
Yeah. See where she started right there at that point.
Oh, yeah, there's that little camp spot and everything.
Teamwork in the job we're doing now is very, very important. It's two guys keeping each other alive, basically. The conditions that we're faced with the turbulence and the wind conditions and the different things that we deal with on a day-to-day basis, it requires trust.
2627.
That's what makes Jim and I a good team, is that we were friends before we flew water bombers together.
Crew that has worked together for quite some time. They know what each other's thinking, what each other's doing, and it gets to the point where there's not a lot of need for conversation in the cockpit between the two of us. We're on the water doing a scoop. The tanks are full. There's no need for him to say probes up. I know the tanks are full. Probes come up. Same thing on final to the fire. I know the drop speed that he wants. I know the flap setting that he wants. I'll set it. He'll acknowledge it. If he's not getting it, well, then he'll obviously say something.
Now, we're just flying over a potential target here. Is there any guys in here? Nothing I know of him, nothing I know of.
Any tanker crew, I think one of their biggest fears is actually killing somebody on the ground. There's been some close calls. We've been involved in a few close calls. Fortunately, nobody's been killed, but when you're dropping 6 tons of water at approximately 120 miles an hour, at 100 feet, the aircraft can create a lot of devastation as far as uprooting trees, and when you see what its capabilities are, you soon realize that a crew caught in a direct hit, it would be pretty devastating. And that's why they have specific drop zones set up where the crews are not allowed within a certain distance of where the tankers are dropping.
Yeah, that smoke's up and down, eh? It cleared right out in that...
As long as it stays up like that, we'll be fine.
We try and do as much as possible to stay out of the smoke, again, because of the hazards that's placed on it, with, you know, flying into the unknown. But there's times you have no choice. So we'll end up running through the smoke. What we try and do is set it up where we're not in it very long.
In the few minutes since the fire was reported, conditions have worsened.
Yeah, Mike, we're just throwing the foam in there blind. She's getting so smoked in there, we can't pick nothing out.
Roger, tanker 262.
The lack of visibility is making the fire plan difficult to carry out, a situation that is frustrating for the pilots.
I don't believe this. Actually, I do believe it. Little wind direction, that's what changed it. Yeah, we'll have to work to get a hold of this one.
One of the difficulties that we're faced with is Mother Nature and the elements. The wind plays a very big role in how we attack a fire and how successful we are in attacking it. When you get extremely windy conditions, you end up getting jump fires.
We got a jump down here?
It's not uncommon to have fires jump 6, 8, 10 kilometers. They'll be lighting up fires in front of them. It's always a concern that once a fire starts jumping, you end up playing catch-up, trying to catch it.
Fighting strong headwinds and thick smoke, Al prepares to bomb the portion of the fire closest to the water.
Check 262. Target is at Compass Boost, jetting out the cutover. Target elevation is 1,500 feet.
Approaching the target, Al sees that the flames have jumped in too many places to control. Although they hit the mark, on the next circuit, it's clear their efforts are useless.
You can see it burning on the mainland, right up at the head, where it's jumped to the mainland. Yeah, Berdog, looks from here, where we are anyways, it looks like it's burning up on the mainland there along the shore. Damon, is there any other tankers coming to this? This fire's gonna go, we're gonna lose her.
I guess a lot of bomber pilots look at it like the doctor-patient stuff. You know, when a doctor loses a patient, he's done everything he can. There's a sense of loss and lack of accomplishment, I guess. And bomber pilots feel the same way. When we attack a fire, it's it's you against Mother Nature, and you know, in that case, Mother Nature beat us, and we lost.
Okay, guys, that's it. Thunder Bay bound. Sorry, couldn't stay and help you a little longer. Okay, bearing 149 from Thunder Bay. 149, okay. Okay, 29 minutes to Thunder Bay. Alright, well, we're batting average. Ain't no shit hot today.
Despite the air attack, the fire spread from island to mainland. It took ground crews 3 days to get it under control and 13 days to put it out. The water bombers lost this one, an unusual day.
It's hard work, it's long, unpredictable hours. Yeah, is it worth it? And I would say, yeah, it is worth it. For me, it's very rewarding flying the water bombers. It's type of flying I like. I consider it the last of the best jobs, and it's a challenge. It's very challenging to fly the CL-215 and to be good with it.